This is module 27, surface area of pyramids and cones. Got to go over what an actual pyramid is. A vertex of a pyramid, which is a special part of the pyramid, is the common vertex of the lateral faces of the pyramid, the faces that actually go up and down. So up and down, up and down, up and down. Lateral faces. And they all come to a point. So that would be called the vertex of the pyramid, which would occur right here. Here's your vertex. The slant height. This is something that some students have a little bit of trouble with, especially when it's on two-dimensional surface, because it's a three-dimensional figure represented on a two-dimensional surface. But a slant height of a regular pyramid is the height of a face of a regular pyramid, which means a face is going to be a triangle, right? And the height of the triangle is the line that's perpendicular from the vertex to the opposite side. We've gone over that before. So what you have to do is you have to visualize, okay, well you have one triangle here, so you have to draw what's called the slant height, because it is on a slant, to get the actual height of that triangle. So, when you drop this part here, the blue, this guy, that's your actual height. And what people do is they get confused with the actual height versus the slant height. The slant height itself is on a slant. The actual height is how high off of the surface the pyramid actually lies. And again, if you draw this actual height, it is going to be perpendicular with the base, whatever it may be. In this particular case, is a pentagonal, so it's a pentagon, so it'd be perpendicular. And if you see, there's a right triangle that's created within it, which means that all the stuff like Pythagorean theorem, trigonometry are all applicable in this. Okay, so we have find the area of a lateral face of a pyramid. So I give you the certain parts. I give you the height here is 15 centimeters. So a regular pyramid, square pyramid, has a height of 15 centimeters and a base edge of 16. And we know it's a square, so that means automatically all of the lengths of the sides of the base are going to be 16 centimeters. It says find the area of each lateral face of the pyramid. So in this case, what happens if you drop this height here, what it does is it basically, the length that you can draw is going to be half of what the actual side length here is. So if we know this length here is 16, we know that this length here is going to be 8, because it's half of the actual base length. So what I've drawn here is I've drawn a blown up version of the actual right triangle. So it's asking for the slant height area, so you have to actually find the slant height. So in this case, we'd have to use Pythagorean theorem. So if you use Pythagorean theorem, you have 15 squared plus 8 squared gives you your slant height squared. If you solve, you should get 17 is equal to your slant height. So now, if we're trying to find the area of one of the lateral faces. So remember, the lateral face is a triangle. So we have this perpendicular segment here. This is going to be your slant height, which is 17. And your base is going to be 16. So all you do is you plug it into the formula, 1/2 base times height. Well, in this case, the height is your slant height. So that would be 17. Your base is 16 times 1/2. You multiply it out, you get 136 square centimeters. And that's the area of one of the lateral faces. Okay, so it says find the surface area of a regular hexagonal pyramid. So you have to remember from a previous module, what I give you, first of all, this is your slant height. This is one of your base sides. And this part here is a pretty important part in modules, a few modules ago, called your apothem. So this is your apothem because we have a regular hexagon on the base. So this is apothem. So what you have to know, it says find the surface area, which means you need to find the area of each one of the figures. So let's do the base, the big B, I like to call first, which is 1/2 your apothem, which we know is 5 root 3, times the number of sides times the side lengths, which acts as the perimeter. So the number of sides we know is 6. Each one of the side lengths is 10. If you calculate that out in a calculator, just do 0.5 times 5 square root of 3 times 6 times 10. That gives you 259.808. I'm going to round it to. And that is feet squared. That's for the base. Now we need to find each one of the lateral heights. So lateral height area. So when you do the lateral height or the lateral area, let's call it lateral area just to keep it the same. That equals your slant height, because it's a triangle, we have 1/2. Your base, which we know is 10, because it's 10 here. Your slant height, which we know is 14. And if we calculate that out, we get 70. Now the thing we need to kind of take into context is we have 6 of these triangles that are slant heights or lateral areas. So we need to multiply this by 6. So if we do that, we get 420 feet squared. If we're trying to find the total surface area, you add up these two numbers, so 420 plus the 259, and that gives you 679.808 feet squared for your total surface area. So again, with surface area, make sure you take into account all of the faces. The bottom part here is a regular polygon, so we had to figure that one out here. And then you had the lateral area, which we had to figure out using the slant height and the base of a triangle, and then we had 6 triangles all the way around the figure. Okay, this is asking for the surface area of the right cone. So what you have to know is that surface area of a right cone is pi times the radius squared plus pi times the radius times the slant height. So all you have to do is just basically know this formula. So we're going to plug in what we know, but if you notice in this figure we don't know what the slant height is. So we have to figure out what the slant height is by actually looking at a right triangle. My height here is 8, my base here is 6, but we don't know what the slant height is, L, so we're going to use Pythagorean theorem. 8 squared plus 6 squared equals L squared. So that gives us 64 plus 36 equals L squared. 100 equals L squared, so that means my slant height when I take the square root of both sides equals 10 meters. So now all I have to do is I just have to plug it into my formula. And the answers that are given here, are actually in terms of pi, so I'm going to keep pi in my answer. So I have pi times the radius, which is 6, quantity squared, plus pi times the radius, which is 6, times the slant height, which we figured out is 10. So if I do this, I get 36 pi plus 60 pi gives me 96 pi when I add it together, and we have meters squared. So the thing to take away from this example is the surface area of a cone is this formula right here. And don't forget your units. Okay, so we have find the lateral area of a cone. That actually requires me to tell you what the lateral area is. In the previous slide, I gave you the surface area of a cone. Well, the lateral area is this part here. That's the area part that actually goes up and down. It's this part of the cone, not including the base, is what it is the lateral area. So it's pi r L. So in this particular figure that I'm given, it's asking for, I'm going to first put lateral area is pi r L, just so I have it and I can look at it. So it says the traffic cone can be approximated by a right cone. So just because I like looking at something a little more exact, here's a right cone, which means that the vertex, drop a height on the vertex, that means it creates a right angle. It's perpendicular. We know the radius is 5.7, so this guy here is 5.7 inches. And we know the height here is 18 inches. So again, we have to use Pythagorean theorem. So we're going to do 18 squared plus 5.7 squared equals the lateral height, which we know L. That's referring to this part of the actual cone. So once you do that, you solve, you get roughly around 18.9. So 18.9 when you use the Pythagorean theorem. And then you can just plug it into your formula here to find out what the lateral area is. So I'm going to do that. We have area, lateral area, equal, so we got lateral area equals pi times 5.7, which is my radius, times the lateral, or the slant height or lateral height, which is 18.9. And you get roughly about 338.4, and it's inches squared. So watch your units. It's all surface area is units squared. So again, the thing to take away from this is what the lateral area of a cone is, which is the pi times r times L.